Yeah. Oh, don't worry.
Guys, watch our games online.
Hi class.
Hi, Mr. Beck.
What day is it? Wednesday. Yeah. I don't know what just happened. No idea. But it's okay. A lot of times I don't know what's going on.
You're set a mental block.
So look at the beautiful diagram I have on the board. Ah, ain't it gorgeous? Alright, Eric, where's Eric?
He's not here today.
You know that? Where's Eric?
He's in there, he is.
He's in there.
Oh my god.
Oh,
Oh my god.
Oh my god.
by the way, Evan, I'm so proud of you. You know why. You'll know why.
I sent it for
Congratulations.
I am.
Wow.
Okay. By the way, I made an error on the homework sheet for tomorrow. I left out a homework assignment. So today's lesson is 45. There's a 45.5 that I didn't put in there. It says 46. So 46 is going to be Fridays, and I have to tonight. So it won't change tonight's homework, but for tomorrow night's homework, you'll see the old sheet's not going to be good. Gabish? Got it? I want to go right to this lesson, and then I'll try to answer your questions. So it's a diagram of a cylinder. You could see it's a huge cylinder. It's 30 feet high, 10 feet wide. It's let's say it's a water tank storing water. It's half full. Can you see that? Say yes.
Yes.
I want to find the amount of work done to pump all that water over the top and out. So let's say there's a little pipe at the top, and we need to pump it up to that top level. What we want to consider is, I took a representative slice of water. Imagine it's water, and it's a piece of frozen water like the shape of a disc. See it? That slice of water has a certain volume and a certain density. So here's the physics of it. Water has a specific gravity. Anyone know what it is for water?
One. That's
No.
Resistance of gravity.
No.
32.
Close. It's 62.5. It's a number that's assigned for water. For oil, it's heavier, it's a little different. For milk, it's different than water. For different substances, it's a different constant. You'll never have to remember what the constant is except for water. You're going to want to remember that number. If you multiply, and I discussed this a little bit yesterday, if this is a volume, it has length times width times height, yes?
Yes.
But if it's made of this foamy stuff, or it's made of gold, it's going to have very different weight. The weight is the force. So we have to know the specific gravity of it. When we're looking at that disk, the volume part is no big deal. It's pi r squared times thickness. We've already done it. But because it's water, we have to multiply by that constant 62.5. Does that make sense so far?
Mm-hmm.
The weight is the force, yes.
So 62.5 is K?
This is not, there's nothing to do with K. That was a spring constant question. We're doing a different question. So it's a different quantity. So if you look in the homework tonight, if it's a different substance, they'll say, and the specific gravity is, and they'll tell you the number. They will also probably tell you for water, but it's one you need to know. So I wanna know the work done to pump them. Remember, work is what times what? Good. Can you estimate the distance that this particular slice, its weight, which is its volume times 62.5, is its force, but what would be the distance? Approximate the distance this one would, this particular slice would have to travel. What is its distance? Yes, Mike?
22 feet.
He made that up. Does it look like he might be right?
Just about.
Yeah.
Possible.
I think I'm right.
Could be.
Let me ask a different question. Suppose this was the very top slice. What would be the distance it would have to travel? The top slice?
15.
Yes. So maybe 22 is about right for this one, yes?
Oh, you're saying.
Each slice has to travel a particular distance and not the same distance. The lowest slice, the one way sitting on the bottom of the barrel, how far does that one have to travel?
30 feet.
So actually, there's a different distance for each slice. They all weigh the same. They all have the same volume times specific gravity, but their distances are not the same. Yes.
30 minus height.
So good. Excellent. So I wanted to get to that. You jumped ahead of me. Let's say this one is at a height of, of y. I'm using y because it's vertical. So what would be, how would you represent the distance that that particular slice, or any slice, would have to travel? Yes?
30 minus y.
Yes. So if it was at the 2-foot level, and it had to go all the way up to 30, 30 minus 2, it would have traveled 28 feet.
Yep.
Yes.
How are the slices going up if you're filling it up from the top?
I'm not filling it up.
Taking
We're not filling it. We're looking at a tank that's half filled with water. The water's sitting there. Hi, water. We're not filling it. The faucet's open. We're pumping it out.
Well, then why is it better to clean like that?
Because let's say there's a, I didn't want to get to this yet. Imagine, if you would, that there was a way to pump this slice and it remained looking like a disc. Pump, 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 gets to the top and it can drip out. We're going to get to another question where we'll see actually a tube here. That's really practically how it's going to happen. And we'll need a machine to pump it out. Find out what the work done for it is. So this actually represents the distance for all the slices, yes? The one that's 1 foot will get its distance, the one at 2 foot will get its distance, the one at 14.5 feet will get its distance. Making sense?
Yeah.
Force for each slice is again volume times density. Volume is not a weight. Volume is its size, but not its weight. So for this question, density is 62.5, but what is the volume of that slice? You have to come up with an idea here, Josh.
It'd be like, I don't know why I raised my hand, I'm sorry.
I don't know either. Right?
So 2 pi times the radius, which is 10.
No. It's the volume times the density. Ben?
100 pi dy.
Yes. I'm going to write delta y, but certainly you were right there. So how did he get there? The delta y is the thickness. Can you see why we choose delta y? So where did you get 100 from?
5 squared. 10 squared.
Say it again?
5 squared, 10 squared.
Exactly. And that was the radius 10. So pi r squared is the area times the thickness gets you the volume of the slice. Volume times density is its weight. Yes?
When you mean density, you mean the gravity of water. No, could you say it's not density?
Each item, I want you to read that page I showed you yesterday. each substance on Earth has a particular specific gravity. For a particular amount, a volume of that amount, it weighs a different amount. Gold weighs more than silver, you know, weighs more than foam or whatever. So each item's gonna have that, and you need to use it. If we were pumping up thick heating oil, it would be a different number here for specific gravity, and it would take more work to pump it out, because it weighs more per unit of volume,
Why do you write density then, because isn't density of water one?
isn't it?
Isn't the density of water?
It's a different, it must be a different unit if you're saying it's one. It must be a different unit. Let me see if I have the unit here.
We use metric system. In chemistry, we're using metric
It's
system.
here. And my unit is pounds per cubic foot,
Oh,
and yours is probably in a metric system.
yeah.
So we answered that question. So what we want to do is write an expression for work, and the work for the kth level of this kth level would be force times distance. Force 62.5 pi times 100. I should probably write this nicer than I did. Times delta y. That's just for one of them. Now here, the radius you can see is the same because it's a cylinder, yeah? So if we wanted a lot of them, not even this thick, but really, really, really thin. Where is this heading? Where is this heading?
To some.
Science.
The final answer equals from,
A,
and we'll talk about A and B, of
62.5 pi.
pi. That's not 100. Wouldn't be much there. In general, it would be pi r squared dy. And this would be in general if it's water. Again, if it's not water, it would be a different substance. What's the question?
don't we have to multiply by 30 minus y, the distance part?
Oh, I left out the distance. Thank you so much. So it really comes after here, but I'm going to stretch it out so that dy is at the end of it. Thank you so much. What did we say the distance was?
30 minus y.
Thank you so much for correcting me. That would do it for this question. And we fill in 100 for R. And really anyway, what's the A and the B? Now this gets a little tricky. What's the A and what's the B? From where to where? Yameen is so cute. She's going like this. And now she's mad at me. Anybody want to answer? Russ?
0 to 15?
Anyone agree to that one? You should have.
This is the water pump.
This was the correct answer for this question. Let's try to understand why. Go ahead.
Is it from the base to the water level or from the water level to the top?
So what we're doing is pumping out layers of water, discs of water. There's no water up here. You're not pumping out air. So wherever there's water, that's the quantities you're pumping it out of or from. So from 0 to 15, that's the interval. Now let's just go through this one more time. I'm probably going to answer your question now. So if we're looking at the level of water that was at 2 feet, we already discussed the pi times 100 pi times delta y times 62.5 is its weight, and its distance is 30 minus 2. We're pumping out that layer in the next